Hello viewers, today in this part of program we will discuss about the instruction set of 8086 microprocessor. In today's program we will discuss about the logical instructions, the string manipulation instructions, the process control instructions and the control transfer instructions. So the instruction set of 8086 microprocessor is much powerful than the instruction set of 8085. Now let us see some more instructions of 8086 microprocessor. Now let us discuss some logical instructions of 8086 microprocessor. The various logical operations that 8086 microprocessor supports are ANDing, ORing, XORing, test operation, then shift operation and rotate operation. Now let us see the various logical instructions. The first one is the ANDing operation. The instruction is AND register 2, register 1. Again in this instruction the register 2 which is defined first acts as the destination. It means after the ending of the contents of register 2 and register 1, the result will be stored as the contents of register 2. The ending is performed bitwise. Similarly, the another instructions for ending operations are AND register 2, memory, AND memory, register 1, then AND register, data and AND memory, data. In all the cases the first defined is the destination and the secondly defined is the source. Some more instructions for ending operation are AND AL, 8-bit data and AND AX, 16-bit data. In both these cases the contents will be ended and the result will be stored as the contents of destination. As in the case of ending operation, the result is stored as the contents of destination. In the same manner we have the instructions for ORing operation, in which the instruction AND is replaced with OR, rest all remains the same. So now let us discuss some of the OR instructions. OR register 2, register 1. It means the contents of register 2 will be logically OR with the contents of register 1 and the result will be stored as the contents of register 2. Similarly, OR register 2, memory, OR memory, register 1, OR register, data, OR memory, data. Then we have some more ORing instructions, that is OR A, data, OR AL, 8-bit data, OR AX, 16-bit data. Now after the ORing operation, the next logical operation is XOR. As we all know, XOR means exclusive OR. Whenever both the bits are same, the result will be 0, and when both the bits are exclusive or each other, means they are different from each other, then result will be 1. The various instructions for performing XORing operation in 8086 are XOR register 2, register 1. Again here the contents of register 2 will be logically XOR with contents of register 1 and result will be stored as the contents of register 2. Similarly, we have XOR register 2, memory, XOR memory, register 1, then XOR register, data, XOR memory, data, XOR A, data, XOR AL, 8-bit data and XOR AX, 16-bit data. All these instructions are same as in case of ending and ORing. Now let us see the next logical instruction. This is the test instruction, TEST. This instruction is more or less same as the ending instruction, but the difference is in the context that the result will be discarded, but the flags will be affected in the same manner as in case of ending operation. The various instructions for test are test REG2, REG1. It means the contents of register 2 will be logically ended with the contents of register 1, but the result will be neglected, but the flag register will change according to the result. Similarly, we have test register 2, memory, then we have test memory, register 1, then test register, data, then test memory, data, test AL, 8-bit data, and test AX, 16-bit data. So these were the test instructions available in 8086 microprocessor. After the test instructions, we have another logical instruction, that is shift instruction. These instructions are used to shift the contents of a register or memory location either left or right by 1 bit. Now let us see the various shift instructions available in 8086 microprocessor. The first instruction is SHR, register or memory. It is also known as shift logical write. In this instruction, we have two categories, either shift register or shift register, CL, or we can say SHR register, 1 and SHR register, CL. Here CL is used to define the number of times we want to shift the contents of that register. While using the shift instruction, the contents of register or memory are shifted left by 1 bit and a 0 will be inserted at the vacant position. SHR means the contents of register or memory will be shifted to right and a 0 will be inserted from left. Now let us discuss the next logical instruction, that is SHL, register or memory, or SAL, register or memory. Here SHL stands for shift arithmetic or logical left. This instruction will shift the contents of register or memory left by 1 bit. The contents of the least significant bit is transferred to left side and the vacant position which is created will be filled with a newly inserted 0. Similarly, the instruction available for arithmetic or logical left shift is SHL memory or SAL memory. After the shift instruction, the next instruction is rotate. For the rotation operation, the instruction available are, first is the RCR, register or memory. This instruction will rotate the contents of a register or memory right through carry. Similarly, the instruction RCR memory will rotate the contents of memory right through carry. Similarly, the instructions available for left rotation is ROL, register or ROL memory. This instruction will rotate the contents of a register left without carry. As we know, if a instruction has C in it, then the rotation will be through carry, and if there is no C within the instruction, then rotation is without carry. So the instruction ROL memory will rotate the contents of memory left without a carry flag. Now the next category of the instruction is the string manipulation instruction. Now let us see what is the string. String is the collection of similar type of data stored in the consecutive memory locations. The 8086 instruction set includes instructions for string movement, for string comparison, for scanning a byte in the string, and for load and storage of the string. A repeat instruction prefix is used to repeat the execution of string instructions. The string instructions end with S or SB or SW. S represents the string, SB represents the string byte, that is 8-bit operation, and SW represents the string word, that is the 16-bit operation. The offset or the effective address of the source operand is stored in the SI register, and that of the destination operand is stored in the DI register. Depending on the status of direction flag DF, the SI and DI registers automatically updated. If direction flag is set to 0, then 8086 works in auto increment mode, and if direction flag is 1, then 8086 works in auto decrement mode. If DF is 1, SI and DI are decremented by 1 for byte and by 2 for word. Now let us see various string manipulation instructions. The first string manipulation instruction is REPZ / REPE. Here REPZ stands for repeat the operation while equal or 0, and REPNZ / REPNE stands for repeat while not equal or not 0. In case of REPZ, the operation is performed while CX is not equal to 0 and 0 flag is set to 1. Similarly, in case of REPNZ or REPNE, the operation is repeated while CX is not equal to 0 and 0 flag is 0. For each operation, the CX, that is the counter register, is decremented by 1, that is CX becomes CX minus 1. The process continues till CX reaches 0. Now let us see some more instructions for string manipulation. The instruction is move SB. It stands for move string byte. This instruction is used to move a whole string byte from one set of locations to another set of locations. The process is governed again by CX register. Similarly, we have an instruction move SW. It is used to move the string word. The major difference between string byte and string word is with respect to 8-bit or 16-bit operation. String byte means 8-bit and string word means 2 consecutive bytes. The another string manipulation instruction is CMPSB, that is compare string byte. It is used to compare two strings having same number of bytes in it. Similarly, we have compare string word, that is CMPSW. It is again used to compare two string words. String word means two consecutive locations form a single word. Similarly, we have SCASB, that is scan string byte, and SCASW, that is scan string word. After the string manipulation instructions, we have another category of instructions in 8086 microprocessor, that is control transfer instructions. Now let us see what is the meaning of control transfer instructions. As we all know, the machines executes the instructions in the sequential manner, that is one after the another. In many cases, it is the requirement of the program to change the sequence of the program after checking the certain conditions. If the condition is satisfied, that is if the condition is true, then the sequence of execution must be changed by making a forward jump or a backward jump, and if the condition is not satisfied, then the normal execution should be followed. For performing these type of operations, we use control transfer instructions. In this category, we use call instructions, return instructions and jump instructions. The control transfer instruction majorly use the flag register. By checking the condition of the flag register, the decision is done whether to change the sequence of execution or to not to change the sequence of the execution. If the condition is true, the program control is transferred to new memory location in the same segment by modifying the contents of IP, that is instruction pointer register. The various control transfer instructions available in 8086 microprocessor are JE address, JZ address, JNE, JNZ, JG address, JNLE address, JGE address, JNL address, JL address, JNGE address, JLE address, JNG address. Then we have JE, JNE, JA, JB and JBE. Now these are the short forms which can be, again we can have their full form, like JE means jump if equal, JNE means jump if not equal, JG means jump if greater than, and so on. Now let us discuss some control transfer instructions of 8086 microprocessor. The first one is JC, that means after the execution of this instruction, if the carry flag is set to 1, then the sequence of execution will change. Then we have JNC and address. Again JNC stands for jump if not carry. It means if carry flag is 0, then the sequence of the execution will change. Then we have JP. Here P stands for parity. JP and address means the sequence of execution will change if parity flag is set to 1. Then we have JNP, means if parity flag is not set, that is parity flag is reset or 0, then the sequence of execution will be changed. We have JNO, means jump if not overflow, means if overflow flag is 0, then the sequence of execution will change. Then we have JO, means the sequence of execution changes if overflow flag is set to 1. Then we have JS, jump to the given address or change the sequence of the program if sign flag is set to 1. Then we have JNS. JNS means jump if no sign, means if the sign flag is 0, then change the sequence of the execution. Then we have JZ, that is jump to the given address if sign flag if the 0 flag is set to 1. We all know the 0 flag is set to 1 only when contents of the result are 0, that means all the bits of the result are 0, then 0 flag is set to 1 and the sequence of execution will change. And the last one is JNZ, that is jump if not 0, means if the result is a non-zero value, then the sequence of the execution will be changed, otherwise the normal execution will be followed. So this was all about the control transfer instructions of 8086. With this we have discussed all the different categories of 8086 instruction set. So friends, in this part of program we have discussed about the logical instructions, the string manipulation instructions, the process control instructions and the control transfer instructions of 8086 microprocessor. We have seen how 8086 can perform the various logical operations on the operands available in the memory or the registers. We have also seen how 8086 can work. The strings are nothing but the collection of similar types of data. We have discussed the various control transfer instructions and the process control instructions of 8086, in which we have seen that how we can check the condition of flag register and we can change the sequence of the execution of the program as per the status of the flag which we want to check. So I hope you all have enjoyed the instruction set of 8086 microprocessor.